Next, we move on to feature engineering with time series features, which we began by basically importing pandas and importing holidays. Then we define a function called define create time features brackets df. Basically, this creates a function to add like new time-based features to the data frame. So here are all the basic time features. So we have df year all the way down to df quarter. Basically, this extracts like the year, the month, the day of the week, and so on to the quarter from like the date, as these features help the models capture like seasonality and trends and periodic patterns in the data. Then we move on to weekend indicators. So df weekend is the weekend is equal to df day of the week greater than or equal to 5, as type is int. Basically, this flags the weekends, so Saturday and Sunday become a 1 while others become 0. Then we move on to holiday features over here. Basically, this block of code basically flags the US holidays in the data, as the holidays can cause like spikes or drops in the sales. Then we have month end and month start. Basically, this flags the first and last day of each month. Then we have like the quarter end and quarter start. Basically, this block of code flags the first and last day of each quarter, as quarterly cycles can basically affect like the sales due to like business planning and like inventory. Then afterwards we do year end and year start. Basically, this block of code basically flags the first and last year of each year, as yearly cycles such as like New Year's Eve, such as like New Year's and year's end clearance can impact like sales overall. Then we move on to feature df is equal to create time features complete df, print feature df.columns to list, and then feature df to head. Basically, this applies the feature engineering to the data and it prints out like the new columns and the first few rows over here. So here's our output. So feature times created are from dates, total sales all the way down until is year end. And here's the first few rows of this data set. Then we move on to creating lag features. So define create lag features is df the target column equal to total sales lags is 1 to 30. Df is equal to df.copy for lags and lags. Df brackets target call lag equals to df target call dot shift lag return df. Basically, what this block of code does, it basically for each values in lag, such as like 1 to 30, this function basically creates a new column in the data frame that contains like the value of like the total sales from that many days ago, for example. So a total sales lag is equal to 1. Basically, this means that this is yesterday's sales, and if it's total sales lag 7, it means the sales was like from a week ago. And this is important as like lag features help the model learn from like past values. Then we move on to creating moving average features by doing define create moving average df target call is total calls. Windows is equal to 3 to 30 all the way down to like return df. Basically, what this block of code does is for every window size from like 3 to 30, it basically calculates like the average it calculates the moving average, and it basically calculates the minimum and the maximum of like total sales over that window. Then afterwards we move on to apply lag and moving averages features. So features is df is equal to create lag features feature df is equal to create moving average feature df. Basically this adds all the lag and moving average features to the main data frame of feature df over here. Then afterwards we print out feature.shape, and then we list all the columns that are created by the feature engineering steps over here. So dataset shapes after feature engineering is 1,455 rows with 42 columns, and these are all the new features created from year all the way down till total sales max is equal to 30. So yeah. And then we move on to creating advanced features. So we did define create advanced features df is equal to df equals df. Then we have sales momentum. So df sales momentum 3D all the way till sales momentum 7D. Basically, what this block of code does, it basically calculates the percentage change over like the past 3 days and the past 7 days, and shift them by 1 to avoid like future data. Then we move on to sales acceleration. Df sales acceleration is equal to df total sales dot diff dot shift 1. Basically, this measures the change in the rate of like sales growth and shifts it by 1. And this identifies the period of rapid change, such as like sudden spikes and then drops. Then we have rolling correlation with other features. So df sales quantity correlation 7 days all the way to sales profit correlation 7 days equal to df total sales dot rolling average dot correlation df total profit dot shift 1. Basically what this block of code does is basically calculates the correlation between like the sales quantity and the sales profit over like the past 7 days over here. Then we have exponential moving average. So df.sales EM 7 all the way down to sales EMA 30 equal to df total sales EWM span 30 dot mean dot shift 1. Basically, this block of code basically computes the exponential weight of the moving averages over the sales of over 7 days, 14 days, and 30 days. Then we move on to seasonal features from df.sign month all the way down to df.cosine day of the year with equal to np.cosine 2 times np.pi dot times df.day of the year divided by 365. Basically, this encodes like the cyclical patterns such as like the month, the day of the week, the day of the year using like the sine and cosine transformation. And then afterwards, we do feature df is equal to create advanced features, features df, and then we display the final shape by feature df.shape and the total features by length feature df.columns. So final data shape is equal to 1,455 rows with 56 columns and the total features of 56.